Hello everyone, I'm Xiang Shouchai. Today, I'm going to illustrate my topic, EEG-based emotion recognition by differential entropy feature. Firstly, I want to introduce my motivation of this project. So why I choose to do the emotion recognition? Emotion is a fundamental aspect of human behavior that plays an important role in decision making, thinking, and social interactions. As artificial intelligence technology continues to advance, emotion recognition has become an increasingly important area of research, particularly in the context of human-machine interactions. Emotion recognition systems can help improve human-computer interactions by enabling machines to better understand and respond to human emotions. So why I choose the EEG signal to do the emotion recognition? There are two types of emotion recognitions, non-physiological signal-based and physiological signal-based. Non-physiological signal-based emotion recognition include facial expression-based methods, have been limited by human camouflage and environment factors, and thus are not always reliable. In contrast, physiological signals such as EEG and EMG have shown promise for accurately reflecting emotion states. And why I use the differential P to do the project? The previous research in EEG-based emotion recognition have focused on features such as the energy spectrum and sample entropy. However, recent studies have suggested that differential entropy may offer better performance for emotion recognition. Now, there are two hypotheses listed in this project. The first is the differential entropy is a useful feature for recognizing emotions based on EEG signals. The second one is the differential entropy in the gamma band frequency range provides better emotion recognition accuracy compared to other frequency bands. I will verify these two hypotheses in the following slides. So I want to introduce my dataset first. The dataset was the EEG signal collected from 15 subjects who was watching movie clips in different kind of emotion. We can see that the first figure is different types of movies which represent for different emotion. And the second figures is the trial to extract the EEG signal from the subjects. And the third figures was the channel distribution in the and how we collect with the 60 channels is as neuroscan system. And now I want to introduce the method we use of this project. First, we will use the bandpass filter to divide the EEG signal into 5 frequency bands and extract the differential entropy from them. The main idea of differential entropy comes from channel entropy. Differential entropy is used to measure the complexity of the continuous random variable and is the entropy of continuous random variable. Differential entropy is also related to minimum description lines. From the equation, we can find that the estimation of differential entropy is equivalent to the logarithm energy spectrum in the certain frequency band. So if we want to get the differential entropy features, we need to calculate the energy spectrum and do the logarithms on it. And finally, we get our differential entropy data in size 5, represented the 5 frequency band and differential entropy numbers, and 62 represented by the 62 channels. And for 3 types of emotion, the positive, negative, and neutral. Next step, we are going to the density estimation for the EEG differential entropy features. The goal of density estimation is to prove the availability of the differential entropy feature in emotion recognition. In this process, only differential entropy feature from one subject, one channel, and one frequency band were used. In this case, we choose subject 1 and channel 62 and the gamma band. The first figure indicates the original differential P feature in three types of boom eclipse. In the beginning, three samples still stay in the same level, and the negative and positive sample increase. From it, we cannot find anything directly, so we need to transform it into the distribution form. We use differential P in each epoch to generate the histogram of data distribution, then assign Gaussian distribution on it. Figure 3 and 4, the distribution and the box plot of the distribution prove that the means of each emotion exist obvious difference among three types of emotion. At the same time, it can prove that differential P is an effective feature to distinguish three types of emotion. And our next step is to use machine learning model to make classification. In this project, four kinds of classifiers were employed, which were k-nearest neighbors algorithm and different kinds of network algorithm. Kn was used to make a simple classification and to prove the availability of emotion recognition of differential entropy feature, and to prove that gamma frequency band can provide better emotion recognition accuracy. From the tables, we can see the frequency band of gamma. We can see the frequency band of gamma provides the best accuracy score in 60%, and the total and the classification with total frequency band provides the accuracy score in 72%. It can prove that the gamma frequency band has a better results. And the neural network algorithm we use were artificial neural network, convolutional neural network, and long short-term memory. AN, CN, and LSTM are used to improve the quality of classification. We can see the structure of each neural network from this table, and we will choose a model with best accuracy as our best model in this project. The performance results was shown in the table. Compared to CNN and LSTM, artificial neural network has a higher accuracy and it spent less time on training than other two models. LSTM took longest time to train, and its accuracy is even worse than k-near neighbors model. That indicates the LSTM layer and convolution layer are not appropriate for this project. They make the network complicated and overfitting. As a result, simple artificial neural network is the best model for this project, and it provides an accuracy in 77%. So the conclusion for this project, we get that through the analysis of data distribution, it was proven that differential entropy can effectively distinguish between emotions. And k-nearest neighbor and the neural network classifiers were used to further verify this hypothesis. By estimation, the accuracy of each frequency band, it confirmed that differential entropy in gamma frequency band provides better results than other frequency bands. Our simple ANN provide the best accuracy in 77% in classification. So it is a relatively great result, but it isn't sufficient to utilize in daily life. If we want to utilize in the daily life, it is at least 90% result is better. But in other papers, it indicates that some models can provide that kinds of the accuracy. So we also know that better models exist, and we need more work in the future to predict better to have the best accuracy. Thank you.